Hello and welcome to another video. Today we have something special. Today I want to dedicate a video about how to measure current on an ATX motherboard because I get asked about that all the time. So I want to give a baseline. We need a motherboard for that. So on the motherboard you have main voltages coming in for the 24-pin ATX and the 12-volt EPS up top here. Here you have the major voltage rails of 12 volts, 3.3 volts and 5 volts. Those run when P is on is connected. And you have 5 VSB. These are the major ones there. And then you have 12 volts EPS separately there. They are the same 12 volts rail, but not on the motherboard, only on the connector. They're most of the time the same rail. The 5 VSB is always running as soon as your power supply has power. And P is on is also always running, which is a 5 volt that detects if it gets pulled low to ground by the motherboard in this case. And that is what we need to achieve. So we need multiple different voltages. There's also like minus 12 volts on here, but that isn't necessary for us for now. So what we need for that is one of these. There's multiple different ones of these. This is a Pico adapter, I think they're called. This takes 12 volts as an input. In this case, on these two pads right there, in this case, I've soldered banana jacks onto them to have 12 volts incoming. And it gives out a 24 pin, as you can see. And it also gives out a EPS 12 volts. And it even can do SATA. So what this does, this converts 12 volts into our necessary power rails and also has the 5 VSB circuitry on here and also the PS on circuitry on here. This is bought online. There are many of these. These are originally used for mining applications because they only have 12 volts incoming and they want motherboards to run off of 12 volts basically. Because they only have 12 volts for every single GPU. And then they can supply also 12 volts only to this to use server-style PSUs. We will come to server-style PSUs as well. So, these are common different models. The most common are like 150 or 180 watts. It doesn't really matter which one you take for repairing motherboards. There are even some 300 watts versions, but that is if you actually want to test something under load. But for actually debugging and repairing like we do, this is plenty fine. These also come with different connectors. Sometimes they can have a barrel jack style on them. But we, for now, you can modify them as you want to just get an actual input into here. Some of these support up to like 14 volts. Make sure of the datasheet of the one that you're getting. This one requires has like a 5% or even 10% that you can go higher on the 12 volts. But we're going to stick to 12 volts. So this is going to do all the conversion of 12 volts into the power supply adapter. So we're not going to worry about this, but you will need one of these. We now want to talk about the 12 volts delivery that we want to get in here. And for the 12 volts delivery, we have many different options. And I will now get this camera, that one, and I will flip it around and we're going to be looking at some stuff on my bench. So let me show you. So because this is my phone, this will be in a different format. So the usual one is to take a lab bench power supply like this one and have it set to 12 volts. That is the easiest way to do that. And in this way, you can even already see the power consumption. This is the easiest way to see power consumption on an ATX motherboard. Next option is right there. You cannot see it properly, but this is a 12 volt server style power supply with a breakout board that I've connected wires to get the 12 volts output. The good thing is this is very high power. This has 100 amps of 12 volts. So this will deliver a lot of current. This thing goes up to 10 amps. Most boards don't take that much, but if you get them into actual stress testing, this won't suffice because they often draw more than 10 amps. But you can also use a server style board like I do and get a this is an 8-pin for GPUs or a 6-pin that you can take to take 12 volts out of them. Another option is what I have under my bench. This is just an ATX power supply. A normal as 12 volt power supply that you can also take to deliver 12 volts. You will have to do some cutting and modifying. As you can see, I did that also. But you can also take 12 volts out of that. So basically any 12 volt source will do. Like if you have a power brick from a phone or something that can deliver 12 volts, you can also use that. And one more thing that I've shown before that is very funny also to use, I can show you that, is this power bank. This power bank can also deliver 15 amps on that output or 12 volts via that USB plug. So I have used this power bank also to power motherboards. So any 12 volt source will do if you have enough amps. I recommend at least 10 amps in order to accommodate for all the voltage spikes. But 5 amps can sometimes be enough if you're in a pickle, but I wouldn't recommend anything under 10 amps. And then the next one is that the lab bench power supply can also be current limited, but we will get to that. Now, I have shown you one way of actually showing you the current. So far we have only seen the lab bench power supply. That will instantly show you the current consumption. That is the easiest way of showing current consumption because you're probably going to have a lab bench power supply already anyways. That is the easiest way in combination with one of these adapters. One more way is fixed solutions of AliExpress. These are just 3D printed cases. They are nothing special. So let me show you what is actually in here. These I have used at the very beginning when I was starting out. This is actually a complete voltage and current monitoring, and all there is in here is these connections that we have right there. These you can buy off of AliExpress. They are not expensive, and all I've done is to wire a 12 volt plug to them and a 12 volt input, and that's all they do. And this receives 12 volts via this one, and then displays it. And the same one goes for this one. This is just in a bigger package, and it can deliver more. It can go up to like 15 amps or 20 amps, and that is all the difference in it. And it just has a big shunt resistor in the bottom. You can't even see that, but it uses basically the same thing as you can see here, just a little bit different display. And I've been using these at the beginning. These were my first ones that I was using because I needed to have a good display of current for the videos, and I was able to use these to show you that. And with these you can put, these can't only do 12 volts, these can do a higher voltage also if you need higher voltage. And yeah, they are easy solutions and ready solutions that you can buy off of AliExpress, and they are easy to wire up also. They show you that in their product video actually, how to wire these up. So if you don't have a lab bench power supply, but yeah, if you have a 12 volts input from a normal power supply, for example, or whatever, this is a good solution, an easy solution to put 12 volts into there and get an power meter. These are not very fast. These don't show every spike, and the display is also not the greatest, but they are fine. They are totally fine for most applications. Let me see if I can power this one up to show you. So this is how this looks. This displays the voltage and then the current under there. There's currently no load on here, so we don't see anything. This is now connected to the server power supply. And these are easy to use. They can be connected to basically anything. And if you watched my videos at the beginning, this was what I was using at the beginning and using to display the current consumption just next to the powers to the main boards. And I was connecting these I was having a different cable onto them to connect to these and show the power consumption. And these work fine. Same goes for the big one that can handle more amps, but this has a smaller screen, but with more information. Let's put the other one onto here. As you can see, this has a smaller screen and also shows amps and wattage. And yeah, these both are totally fine for this use. But I wasn't happy with that. And I went further into creating an own power supply. These solutions that I've shown you so far all rely on a screen that you can have a look at. My biggest problem is that these screens are often very hard to see because they are captured through a camera. If you're sitting in front of them yourself and looking at them, it's easy. But I wasn't happy with that. I wanted to have digital communication in order to see the power consumption. And I've looked online for solutions, and there are power supplies that you can buy with USB communications, but they are around 200 bucks if you want to get 12 volts with like 20 amps or something like that, or 15 amps. And I wasn't ready to pay that. So I was browsing around the internet, and I have actually found a current measurement and a voltage measurement tool that is called an INA260, which is a small chip on a developer board. I will show you that. And this is the small developer board that I was talking about. This is the star of the show, the INA260. It takes the incoming 12 volts there. This is the outgoing 12 volts, and it has an internal shunt resistor, which it measures the voltage drop off, and with a 60-bit ADC, it converts it into a signal that it can output via SDA and SCL, which is I²C. And yeah, this thing can handle up to 15 amps, as you can see, and the from 0 to 36 volts, which is very good for my application. Here, as you can see, INA260 precision DC current power monitoring, and the logic of it uses 3 to 5 volts, so a normal USB power supply suffices very well with that. And based on this, I based another version of a current meter, which is this thing that we have blown up in one of our previous videos. There's an Arduino Uno at the bottom of this, right there, which has a micro USB there. You have the INA260 that is connected via these two via I²C to the board. And then we have some banana jacks just somehow forced into this. And I 3D printed this case. The case is broken because I had to replace that chip in there that is on there, because I've blown that one up. And also there's a screen, an small OLED screen at the top here, connected also via I²C to that Arduino Uno, and which displays those values. So I'm gonna be honest, I wrote the code for this with ChatGPT. I can code, but ChatGPT is way quicker for that to code. And I do understand the code that it has written, which is really important. And what I can do now, this can now take a input right here, and it connects via micro USB right there. So let me show you this version. You've probably seen it in my latest videos, because this is what I most of the time have used. So now let's connect this up to the PC via micro USB. You can see a small OLED, and it shows a voltage and amperage. And it takes banana jacks, which is very convenient for basically most of the tasks. So you put in the banana jacks right here, and you get shown 12 volts at how many amps. And there will be an amp draw if we, for example, put a load onto here. Now we can see 22 milliamps. And this now can communicate also with my PC. As you already most of the time saw, the communication was down here. Let me get that onto display. So the Arduino Uno in here communicates via serial to USB with the PC and puts out this. And this is written in a C++ to get a program that can read that out and display that. Also written by ChatGPT because, yeah, I have never written something with a serial output, but yeah, everything was done via that. And now I have a actual readout on this on the PC that I can capture and easily show you, because that is way easier to read out than that. But I wasn't happy with this solution, because if you've seen, this is a sandwiching of multiple boards and botch up with multiple wires, but it worked for a long time. But there's no current limiting here. That is a big problem, because this just measures current and voltage. And this is why this was blown up in one of my previous videos. But the good thing is, it takes any input. Again, no matter what power supply you're using, even if it's a power bank, this will show you the current and amperage up to 36 volts, up to 15 amps. And even with good precision, like in a milliamps. So I wasn't happy with that version, especially because one of this has blown up before, as you saw maybe in one of my videos. And at this point, our sponsor of this video comes in, which is PCBWay. If you have had a good look at what is on my bench, you might have already seen what I've been thinking about doing. Many people have asked me, and I've been telling them that I'm doing my own current measuring device. And what I came up with were these PCBs. Let's get a zoomed down view. These PCBs are basically what you saw in this small version right here, but tidied up with its own connections. This is the first revision of the board, which is a little bit bigger than this one and had some flaws still in it. And this is the next revision that is improved. And this is based on an RP2040, a microcontroller, the INA260, a fuse that you can put in there, and again banana jacks that can be soldered on there, and has debug LEDs. This is the non-populated board. And right here, I have a populated version. This is how this will look like. And I have another version. Let me grab that. This is also a 1.0 version where I had a soldering error. And this then has a display here and an SPI display here. And yeah, after that, I wasn't happy with some of the soldering that I did and some of the PCB layout, and this version came to life. And for this version, there's also ready ones, like this one already works, and this one also works. This also takes now USB-C instead of micro USB, and takes again an input right there, and puts out an output, and can display this on this screen or this screen. But I'm not going to show you this version. We are going to move up to version 2.0. But before I'm going to show you the end product of version 2.0, I want to thank our sponsor, which is PCBWay, like I said before. They have helped me to produce these ones. They have provided these PCBs for me free of charge. And I've ordered 10 of each of them. And they have really good turnaround time. Like I got these PCBs within 3 days or 4 days, I think, or something like that, which was ridiculous. Like, it cost something. The shipping is what takes some time, and they will take because they ship out of Shenzhen, out of China. But I got PCBs within a week of sending them the Gerber files, and I want to show you their internet site actually. So this is their website. They do standard PCBs, advanced PCBs, flex PCBs even. They do assembly service if you could not do that yourself. They do CNCing. They do sheet metal fabrication. They do a lot of stuff, and we are focused on the PCB stuff. And they do various thickness. They do multiple layer boards. You can even select the solder mask, what color they are. I just chose the standard green one because I like that, because you can see the traces very well. You can select the thickness of the copper right here down there, and you can even select assembly service for them. And they're doing a great service, like the stuff that they do. You can also pick aluminum and copper based PCBs so that have good heat sinking. Let's go back to the overview. And they have kindly sponsored us to be able to make these PCBs happen. And I want to show you the actual like product that I have now, which are these two. These are the finished boxes. You can see one has a big display, one a smaller one. And yeah, the base is not the same. The base is the same, and then the lid all varies depending on the size of the screen. These are both OLEDs, both via I²C. And I designed this for the lid to be magnetic. As you can see, it pops off and on very easily, and you can see the finished product right there. This is an RP2040, as you can see, as the microcontroller, which has USB-C right there. Then you have the banana jacks. This is the input, this is the output, black coded as ground, and the positive coded as blue. Then you have debug LEDs. These debug LEDs show 5 volts, so the incoming 5 volts. Then it shows the incoming voltage via that one, and if the outgoing voltage is reaching there. So if the INA hasn't blown, and there's a fuse also there. I put in 15 amp fuse for now in there for testing, and this will show if the fuse is broken or not. Then there's also a header this time, you can see, so you can just use 2.54 DuPont cables in order to connect these, so no soldering required. And also there's more GPIO pins from there routed there, so you can put more SPI ones, more pins into here in order to either connect the RP2040 to another module for whatever you want, or an SPI display if you want, for example, a color display. And yeah, so this is how this one looks like, and this is the same thing, just with a bigger display. As you can see, this is the same thing, and it has also mounting holes in there to be mounted properly. So this is very secure, it cannot go anywhere in there, and this just snaps on, if you can see. And I made this version particularly for the YouTube channel, so that you can also see the current on there. And let's now get them actually hooked up. So this is now hooked up, and let me connect this to the actual output here. So, and now we can see the synced up version, that the values that are displayed here are also displayed there via USB-C this time. And if we now take our 12 volts and supply them, as you can see, black to black and red goes to blue in this case, we now have 12 volts there and 12 volts there, and still when we now take off the lid, we can now see all of the LEDs lit up. If we now take off the 12 volts, we now see only a single LED lit up, which is the USB. And as soon as 12 volts is on there, we have 12 volts to these LEDs, which means we have an input 12 volts, and the 12 volts also reaches our output. Most of the time you won't be able to see those though, because you will have the lid on. These are only for debugging later. And then we can connect an output to these. In this case, also again, we have color coded, the blue one going to positive and the black one going to negative. And now you can see a power draw. This is from this thing. This has a passive power draw. And the same power draw you can see right there. It updates quite quickly, and with this big display, it's already also nice to see if you go into the overview. Like you could see this currently is very reflective. Let me take off that peel that is on there still, so it's not that reflective anymore. Now it's not that reflective anymore. Now you can see that better. So this is a great way to show that, and this is an even better way to show that, the power consumption. And that was what was important for me to get within this power meter. So I recommend you to build this up yourself if you want to make an own current meter. Like all you need is some kind of microcontroller. I in my case use an RP2040. You can also use an Arduino Uno that costs like $2 that I've used here. And then this OLED display, you can use a OLED display, for example, and you can get this module, the INA260, in order to connect this for current consumption. And this is a very easy way, or not very easy, it will take some time to get into that, but I think it's a great project to do something yourself and actually get a power consumption reading. Like this one is very big. Like on screen it looks tiny, but this screen is huge. Like before I've been using this small one, and the other version is a little bit smaller OLED, and it shows the same thing. But this isn't as easy to see on the video as is this one that I will be using for now on. And yeah, these are the ways of how you can measure current. I will make sure to add the different kind of things that you will need in order to make this yourself, or either use a lab bench power supply, or I will also link these ones if you want to make it this way. And if you're feeling fancy, you can design one of these yourselves, as I showed you what modules you will need, and I will link them in the video description. And this is what you will need to show power consumption on a ATX motherboard. So most important thing is the adapter that you need, because we only measure the 12 volts that is going out there. Then you will need some kind of current measuring device like this one or these ones. And then you need a 12 volt source like a standard ATX power supply or a 12 volt PSU. And a lab bench power supply can do both things in once, so that makes it very easy. So if you have a lab bench power supply, you can just revert to this thing and have everything in one go. So I hope you enjoyed the video. I hope it was interesting and you actually could learn something from what I was doing here. Like, such a small thing can go very big, and I've invested many hours into designing this board, optimizing it, writing code. Well, I didn't write the code, but you know, you get the gist of it. And yeah, and soldering it together, designing the housing for it, that everything fits onto there. And yeah, everything will be linked in the video description. Thank you very much for watching. This was Mainboard Medic. Thank you very much, and goodbye.